Welcome to my YouTube channel Cognara. I'm Michael, your science and technology educator. Today, I'd like to explore a quiet but astonishing question that sounds simple at first, yet opens the door to one of the most dramatic thought experiments in physics. What would really happen if Earth stopped spinning, not forever, not for hours, but for just 5 seconds? It feels like a harmless pause, something we might barely notice. But when we look more closely, those 5 seconds begin to reveal how deeply our lives depend on a motion we never feel. Right now, as you sit listening to this, Earth is rotating at about 1,000 miles per hour at the equator. We don't sense that speed because everything around us, the air, the oceans, the ground beneath our feet, is moving together as one system. That shared motion creates a quiet balance. It allows days and nights to pass gently. It shapes the winds, guides the oceans, and even influences the way storms are born and fade away. So let's imagine, calmly and carefully, that this motion suddenly stops for 5 seconds. Not gradually, not gently, but instantly. The planet itself freezes in place, yet everything on its surface keeps moving forward at the same speed it had a moment earlier. The first thing that happens is not a sound or a flash of light. It is pure motion continuing without the ground beneath it. People, buildings, cars, trees, oceans, and clouds are suddenly no longer attached to a spinning world. At the equator, where Earth's rotational speed is highest, the ground had been moving eastward at about 1,000 miles per hour. When the planet stops, the surface halts, but everything on top of it keeps going. In practical terms, this means that every object, including the air and the oceans, surges eastward at jet speed. Cities would experience a violent horizontal force far beyond the strength of any earthquake. Buildings that were never designed to resist such sideways motion would begin to collapse. Roads would tear apart. Power lines would snap. Anything not firmly anchored to bedrock would be flung forward. The oceans would not behave like a single wave. Instead, enormous walls of water would surge out of their basins and race across continents. These would not be ordinary tsunamis caused by earthquakes. These would be global floods driven by inertia, sweeping coastlines clean and carrying ships, ports, and entire cities inland. Even far from the equator, where Earth's rotational speed is slower, the effect would still be devastating. At mid-latitudes, the surface normally moves at several hundred miles per hour. That is still faster than most hurricanes and far beyond the tolerance of natural or human-made structures. Forests would be flattened. Mountainsides would experience massive landslides. Rivers would leap out of their channels and carve new paths through the land. The atmosphere would behave in a similar way. The air would continue moving eastward at high speed, creating winds far stronger than anything recorded in human history. These winds would strip soil from fields, rip roofs from buildings, and carry debris across vast distances. The sky would darken with dust, water vapor, and fragments of the world below. Now imagine that after 5 seconds, Earth starts spinning again at its original speed. The surface suddenly begins moving eastward once more, but everything that was thrown forward is now out of place. Water that surged inland begins to crash back toward the oceans. Air that rushed ahead collides with the restarting rotation. The result is a second wave of chaos, as opposing motions meet and mix. From a human point of view, this entire sequence would unfold faster than it takes to take a deep breath. There would be no warning, no time to react, and no meaningful way to survive in most parts of the world. Yet what makes this scenario even more striking is not the destruction itself, but how quietly it emerges from basic physics. This is not about explosions or exotic forces. It is simply inertia, the tendency of moving things to keep moving unless something stops them. Earth's rotation gives everything on its surface a shared sideways speed. When the planet stops, that shared motion becomes a destructive force. But there is another layer to this story, one that unfolds more slowly and speaks to the deeper role of Earth's rotation in shaping life. The spinning of our planet does more than create day and night. It drives the Coriolis effect, a subtle influence that bends the paths of winds and ocean currents. This effect helps organize the great circulation patterns of the atmosphere. It guides the trade winds, shapes jet streams, and steers hurricanes. It also helps drive major ocean currents like the Gulf Stream, which carries warmth from the tropics toward higher latitudes. If Earth stopped spinning, even briefly, those circulation patterns would be severely disrupted. Winds would no longer curve in familiar ways. Storm systems would lose their structure. Ocean currents would begin to drift and weaken. Over time, this would alter weather, shift climates, and change where life can thrive. In our 5-second scenario, the immediate damage would overshadow these slower effects. But if such a pause was somehow repeated or extended, Earth would gradually become a very different world. Heat would build up differently. Rainfall patterns would shift. Some regions would become far hotter and drier, while others would grow colder and wetter. It is worth pausing here to notice something quietly profound. Earth's rotation feels like a background detail, something abstract we learn about in school and rarely think about again. Yet it is one of the invisible foundations of everyday life. It shapes the length of our days. It guides the winds that carry clouds across the sky. It moves the oceans that regulate global temperature. It even influences the subtle rhythms of ecosystems. We live inside a system of motion so stable and so familiar that we forget it is there at all. When we imagine Earth stopping for 5 seconds, we are not just imagining a disaster. We are briefly stepping outside that system and seeing how finely balanced it truly is. The calm continuity of daily life, the gentle passing of time, and the predictable rise and fall of tides all depend on this steady spin. In reality, Earth will not suddenly stop rotating. There is no known natural process that could make that happen. The planet's angular momentum is conserved, and changing it significantly would require an astronomical event far beyond anything humanity could cause or survive. So this thought experiment is not a warning about the future. It is a way of understanding the present. It reminds us that beneath the stillness we feel, beneath the solid ground we trust, there is constant motion. We are passengers on a vast rotating world, moving through space at thousands of miles per hour, carried by forces that rarely make themselves known. And perhaps that is the most beautiful part of this story. The same physics that would bring chaos if interrupted is what quietly keeps our world livable, stable, and gently alive. Every sunrise you watch, every ocean breeze you feel, and every slow drift of clouds across the sky is a soft expression of that hidden motion. Earth is always spinning. We are always moving. And yet, to us, it feels like stillness. Thank you for exploring this thought experiment with me today. If you enjoyed this calm journey into the physics of our planet, you may want to explore the next question with me. What would happen if Earth's gravity suddenly changed, even slightly? Until then, this is Michael, and you're watching Cognara.